Okay, guys, tomorrow is your official mock star. I have covered almost everything. There might be one, maybe two questions that I haven't covered. That means last time I took a lot of stuff off that's not coming off this time. It's going to be a major grade and almost the whole test is counting. Factoring. The nice thing about factoring is it would probably have to be a multiple choice question. So if you were really bad at factoring or forgot how to factor, you could at least, I hope, guess and check the answers. It would be a shame to miss a factoring question. Now, how did we learn how to factor? We guessed and checked. The first two positions have to give you a product of 6x squared. Well, that could be 6x and 1x or 3x and 2x. What do you want to start guessing with? I usually guess with the ones that are closer together, so I started with 3x and 2x. The last two positions have to give you this product. It's the middle that's tricky, because the middle comes from multiplying, and adding those. Okay, so 6. The 6 on the end could be 3 and 2 or 6 and 1. I started guessing with 6 and 1. I put the 6 here and the 1 here. That gave me 12x and 3x on the insides and outsides. Can that ever make a negative 5 when you add them up? Then I put the 1 here and the 6 here. That gave me a 2x and an 18x. That certainly can't add up to 5. So that told me, hey, you might need to adjust your guess. I wasn't ready to give up on 3x and 2x yet. I want to try, for that back 6, I'm going to try 2 and 3 instead of 6 and 1. And that was the winning combo. If I put a 3 here and a 2 here, that's going to give me a 4x. And on the outsides, I get 9x. That can make negative 5. If this is negative and this is positive. Please check everything, though. Make sure that last sign works, too. A lot of kids mess up on the very last sign. So you would have had answer choices here that you could have checked. 3x times 2x is 6x squared. Then you get negative 9x. Then you get positive 4x. And on the end, you get negative 6. So that would have been the winning combo right there, because those two add up to negative 5x in the middle. Is it coming back to you? We spent weeks doing that. Well, that's what factoring is. All right, number 2. You can do this by dividing. I heard a lot of you say dividing. That's perfectly simple to do. You also could have just kind of thought of it like backwards. 3x to the 4th y squared times what missing factor would equal 21x7 y5? What's the coefficient got to be? 7. 3 times 7 is how you get 21. My x's went from x to the 4th to x to the 7th. X to the 3rd. My y's went from y squared to y 5th. That was the missing dimension. Alright, slope. Now, I have seen them give you a linear function and ask for either slope or y-intercept, and it could be one of those questions where you have to bubble in the answer. Please listen carefully to this. Jesus, don't even think about it. If you get an answer on a bubble-in question that's a repeating decimal, that's a clue you probably should go back and redo it. I have never seen them give a repeating decimal bubbled answer. Okay, so I have seen decimals. Like this one's a decimal. Negative 5y equals negative 3x plus 20. Divide everything by negative 5. What's the only thing they asked for? The slope. Negative 3 divided by negative 5 is 3/5, but I cannot bubble in 3/5. What would you bubble in? 0.6. You would have to bubble in the decimal version. 0.6. Okay, now today we are learning one new thing, and then we're going to go back and review some things that we that growth formula and decay formula. We kind of did that really fast. But first, let's talk about scatter plots. Get your notes out. Scatter plots. You guys have seen scatter plots. We're just going to take it one step further than what you did last year. Yeah, didn't y'all do scatter plots last year? That's an 8th grade concept. Okay, a scatter plot can be used to graph two sets of data against each other to see if there's any kind of relationship. They use the word relationship, correlation, and trend kind of interchangeably. So if you see those three words, we're trying to see if there is any kind of trend, if there is any kind of correlation between the two variables, or any kind of relationship. Sometimes you'll find a positive one, sometimes a negative one, sometimes no relationship at all. Okay, look at these two pieces of data, and this would be if you surveyed a bunch of people. Let's graph study hours against grade. What kind of relationship do you think that's going to have? In general, and I'm not saying it always is true, but in general, as your studying time increases, so does your grade. In general. Now, is there exceptions? Sure. For a kid, there's some kids who are really smart, don't study at all, but they still have a real high grade up here with hardly any study hours. Also, those poor souls who study a lot and still make a low grade. That happens too. Those are called outliers. When you have one or two pieces of data that doesn't really follow the general trend, and lots of times they just take the outliers off. Okay? So, in general, yes, this would have a positive correlation, a positive relationship. Something that has a negative correlation. Let's say as years go by, what happens to the value of a car? Okay, again, there are exceptions. If you have a classic car, then yes, sometimes as the years increase, it's going to be worth more. But in general, the car's on the road 9 times out of 10. The longer you drive it, the more miles you put on it, the more repairs it needs. What's happening to its value? It's going down. So time is going up, but value is going down. And then you can have data that really has no relationship. How about temperature and age? Exactly. The temperature outside and the age of the kids in the school. Is that going to have a relationship? Also, sometimes if you see data that lines up in a horizontal or vertical line, that's also no relationship. If they're scattered all over the place, or if it's completely horizontal or completely vertical, there's no relationship there. Now, another thing that they ask you to do this year is to talk about how strong a correlation is. Sometimes they give you a picture. Let's say we have a positive correlation. I'm going to draw two different positive correlations. Which one do you think is stronger? Yes. The closer the dots are together, the stronger the correlation is. This would be a strong positive. This would be a weak positive. And the same thing can happen with negative correlations. The tighter the data is together, the stronger the correlation. And we're actually going to learn how to find a number that tells you if it's strong or weak. It's called the correlation coefficient. We're going to get there too. Okay, so do I need to draw the weak ones? Y'all understand you could have strong, weak, and you could also have, strong negative or weak negative. Are you okay with that? Okay. I also want to teach you or review with you some calculator skills. I am going to show you a real-life scatter plot. We are going to graph the dots. Now, if you're given data from a scatter plot, you have to put in all of the data. Okay, so here we go. These are our x values, these are our y values, and we're going to look at this scatter plot. We're going to determine if there's any kind of relationship. We're going to determine if there is a relationship, if it's strong or weak, and we're also going to do the correlation coefficient. First thing I need you to do, and it's going to take a while, the hardest part about these problems is the data entry, punching in all the numbers. Go to Stat Edit and put in every single one of those points. Okay, please just do it. Okay, all I want you to do right now is put the data in. Don't do anything else. The numbers are, y'all know what a geyser is? Okay, so this is graphing how long the geyser is going off versus how long in between the times that it's going off to see if there's any kind of correlation. So that's what this data is about. Okay, well give me a minute and I'm going to show you. Please double check yourself. Like I realized I left off one of my pieces of data, so be careful. Okay, do we have it all entered? Okay, now, what I want to do, and we did this, but it's been a while, is I want us to get the calculator to just graph the dots for us, just so we can see if there's any kind of relationship. Okay, make sure you're in Zoom 6, because I want to also practice. We're going to have to change the window in a minute. Zoom and then the number 6. That's your regular screen from -10 to +10. Alright, go to y equals. You shouldn't have anything in y equals. Clear anything out that was already there. To get the calculator just to graph the dots, which is a skill you need to know how to do. You go up to plot 1 and hit enter, and it should be highlighted in black. And that way it's just going to graph whatever dots you put into the stat edit. It's going to graph them as points. Well, it actually looks like little squares. Now, when I hit graph, it should show me the dots. But, unfortunately, in Zoom 6, in the standard screen, we're not going to see it. Because that's where we normally are, Fernando. Why do you have to question every single thing? Alright, now, this is a good lesson on how to adjust your window. Using the data you're given to use that as a clue to change your window. The X values, looks like the lowest X value I have is 1.5 and the highest X value I have is 5. Usually in real life situations, I make my X minimum 0 and my Y minimum I usually make 0 as well. So I'm going to make my X minimum 0. What's the highest X value that I need? 5. Scale means what you're counting by, and we are going to talk about that in a minute too. My Y values, again, Y minimum, I'm usually going to make it a 0, but what should my Y maximum be? Around 80. The highest number I see is a 79. I'm going to make it 80. And then when you hit graph, you should see the dots. Do you think there is a relationship here? Yes, there's definitely a positive correlation. Do you think it's strong or weak? It looks pretty strong to me. And we're going to find the correlation coefficient in just a minute, and we'll find the exact, we can tell if it's strong or weak from the number. Okay, now I also want to graph the line of best fit. When you have, yeah, don't, you want to stay with me. You got to go back and enter all those points again then. Okay, we want to find what's called the line of best fit. So we already have all those points in, unless you were stupid and deleted them. And now we're going to go back to stat, calculate linear regression. It's not going to be a perfect line, but it's going to give us a trend line or a line of best fit. It's just like finding the equation of a line. It's just not going to be a perfect line, because the dots were not in a perfect. So look at the slope. It's not an nice whole number, neither is the y-intercept. At least give me 3 places behind the decimal. So I'm going to make a note to myself. The slope is 12.158. The slope was 12.158. And what was the y-intercept? 19.104. Okay, now I'm going to go ahead and graph that line with the data that I already graphed. I'm not going to take the plot off yet. So y equals 12.158x, oops, I forgot the 8, plus 19.104. So we can see what that trend line looks like. A trend line should have some of the data points above the line, some below, and maybe even a couple on it. So does that look like a good trend line? Yes. Okay, I get the point. I get the feeling that not everybody is paying attention, and I'm telling you, you're going to have questions like this tomorrow. All right, now correlation coefficient. I want, because they will ask you that. It's a number, it's a value. The nice thing is the calculator can find it for you. So let's go back to our notes so we can talk about what correlation coefficient is. Okay, put this in your notes, please. Correlation coefficient. Guys, I don't care what you write. We'll see. We'll see how good your grade is tomorrow. All right, correlation coefficient is a number between -1 and +1 that indicates if there is a relationship between the data and how strong it is. So it'll tell us if there is a relationship, and if there is one, it'll tell us if it's weak or strong, just by looking at the actual value of the correlation coefficient. If you have a correlation coefficient of 0, that tells you there is no relationship, no trend, no correlation. If you have a correlation coefficient of 1, that's called a perfect positive relationship or correlation. If you have a correlation coefficient value of -1, that's a perfect negative relationship. Perfect negative correlation. Now usually it's not one of those numbers, it's somewhere in between. The closer you get to +1, the stronger your positive correlation is. The closer you get to -1, the stronger your negative relationship is. And if you get really close to 0, that probably means there is no relationship. Don't delete it yet. We're going to use it to find the correlation coefficient. So, let's say you had a correlation coefficient of this is just an example, you don't have to write this down, 0.8. Well, it's not perfect, but it's a pretty strong positive. It's not perfect. Perfect would be exactly 1. But it's pretty strong. What if you had a 0.5? It's not perfect. It's definitely positive, and it's not really called strong or weak. It's in the middle. A correlation coefficient of 0.3. Weak. There is a positive relationship, but it's weak. And if you had like 0.1, that's probably no relationship. That's closer to 0. Now, in general, for positive relationships, if it's 0.7 or bigger, that's usually a strong positive. If it's 0.3 or smaller, that's usually a weak positive. You see what I'm saying? If it's exactly 1, it's perfect. Same thing for the negatives. A negative 0.7 is a strong negative. And so negative 0.8 would be strong negative. Negative 0.9 would be a strong negative correlation. If you had a negative 0.3, that would be a weak negative. I'm going to tell you how to find it. I just want you to know how to interpret it. What? So usually they use those indicators as whether it's going to be strong or weak or no correlation at all. Okay, so if you had a correlation of 0.753, strong, positive. If you had a correlation coefficient of 0.20, well, that's really, really weak, almost bordering on no relationship. I don't think they would give you numbers that were not fairly obvious. Okay? Now, how do we find it? This is how you find it. You have got to find the catalog. There is a catalog button on your calculator, and it's on the 0. Do you see the 0 key? Look what's written above it. Catalog. Now, the catalog is going to have a huge list of lots of things in alphabetical order. We're trying to find diagnostics. And we want it, there's two. It says diagnostics off or diagnostics on. We want to find diagnostics on. Okay, so I'm going to go to the 0. Above the 0 is catalog, so second function 0. And it starts with the A's. I just scroll down and down, down until I see diagnostics. And I want diagnostics on. And then you have to hit enter twice. So here's my little arrow on diagnostics on. Enter and then enter again until it says done. Okay, now once your diagnostics are on, then we're going to do that whole process again. We already have our points in there. We already did the stat edit. Now we're going to go back to stat calculate. Just like how we found the trend line. Calculate the linear regression. The only difference is now it's also going to put some extra information out there. It also tells us what the correlation coefficient is. Now they use the letter R. R is, ignore R squared. That's for something else you'll do in statistics. Look at R. What is the value of R? 0.938. So what would we say that relationship is? That is definitely strong positive. Don't worry about R squared. If you had what I had, then it's right. It gives me the slope and the y-intercept again, but it also tells me that R. R is the letter they use for correlation coefficient. Okay, so lots of stuff we learned there. You got to remember how to get to it. Catalog, which is on the 0, and then turn diagnostics on. All right, let's reset your calculator. Everybody reset it, please, because we're going to be putting in some different data. So, second plus 712. All right, I want to go back and look at exponential growth and decay because we did just one day on it, and they really, really liked that last year, so they might like it this year. Some of these problems you should recognize because you took them on the first mock that you did, and I am going to give that back to you. Okay, can y'all read that? Turn the light off and see if that makes it better. Okay, all that says at the top is this is an exponential function. Okay, so here's an exponential function. You should know what exponential functions look like. Remember what this thing is called right here? Asymptote, which means it will never ever, this leg of the function will never actually cross that asymptote. What is the equation of this asymptote? Y equals 0. It's the x-axis, which is y equals 0. It's never going to go below that. Now, I have seen them try to trick kids by talking about this as an asymptote. Is that an asymptote? No, because this is going out forever. This would absolutely cross that line eventually. It's going up and out. Exponential functions do not have vertical asymptotes, only horizontal. So keep that in mind. All right, now we want to know, based on this graph, which of these things is true. Please read through those in your head and pick which one you think is true. In your head. All right, and what is it? C. The range is the set of all real numbers greater than 0. What's the domain of this thing? All real numbers. Range. Now this is where I'm afraid they might try to trick you. In the past they've given two separate answer choices for range. Y is greater than 0 or Y is greater than or equal to 0. And kids have fallen for the wrong one. Which one's correct? This one. It will never ever, even look, it looks like it's right on the line, but it will never actually cross that. Exactly. It's very close to 0, but it will never actually equal it. Okay, let's try another one. Do y'all remember that question? I think it was on the last mock you took. Can I do what? Yes, we will get to that one. All right, here is another one. Now, I didn't count this one last time because we hadn't learned about it, but we know about it now, so I will count it. Now, I also want to talk about how we can do this one in the calculator now. The formula is y equals the initial amount, parentheses 1, it's either going to be a plus or a minus, whatever the percent as a decimal, to the time power. It's plus when it's going up and it's minus when it's going down. Is this going up or down? Up. Okay, so the initial amount. What's the initial amount here? 29,000. What's the rate of increase? 6.2%, which we would have to change to 0.062. Keep that in mind. Let's put this into our calculator then. Go to y equals. Go to y equals. We're going to put in 29,000. That's our initial amount. Oops, I think I put too many zeros. 29,000 parentheses 29,000 plus parentheses 1, not plus, I'm sorry, parentheses 1 plus, now I got to change 6.2 to 0.062, close parentheses. Now I've got to raise it to a power. That's this little symbol above the division sign, and that the exponent is where your input goes. That's your x. The input is your x. That's what makes it exponential. Now, if I hit graph, I'm not going to see any of this because I'm not in the right window. So we're going to use our answer choices here to set up our window. Okay, so look at my x values. What should my x values go start and end? 0 to 10. So my window, I'm going to go from 0 to 10, and scale means what I count by. I'm going to count by ones. Look at the y values. What should they go to and from? They should start at 0. The lowest y value showing here, 0. And they should go up to 50,000. Now, scale. What do I want to count by? By 5,000. And then I should get a pretty decent picture. Okay, now, look at these answer choices. I know when you guys did this, we hadn't learned this lesson, but I think some of you thought this was pretty easy. 2 of them you should be able to eliminate right away. C and D, because they start at 5,000. So we're looking to see which picture matches. Look at my calculator. What matches the best? A. These two match. This one's going up way too fast. That's definitely higher than a 6.2% increase. That's like a 62% increase. They're trying to trick you here. All right, look at this one. Now, there is a very easy way to do this, but I also want to show you another little thing you can do in the calculator. Do they tell you what kind of function this is? What kind? Exponential. And they give you points. Where do they go? Where do you go if they give you points? Go to stat, please, and let's put those points in. Andrew? You said it too, so you want sentences? Then we can do that for sure. Okay, now I've got my points in. It is an exponential function. When I go to stat, calculate, I'm looking for something that says exponent. I've got to scroll all the way down to Number 0. Okay, it's going to give me the equation. It tells me 0.0625 is A. And it tells me that B is 4. So which one matches that? H. The initial amount was 0.0625. And the amount of increase, it's quadrupling, it looks like. It's getting 4 times bigger. Okay, now, did you have to do that? No. If they give you equations, please stick with me, folks. You never, ever, ever should miss anything where you're matching an equation to points. I'm going to go straight to the right answer. You could have just guessed and checked. I'm going to put in the right answer, which was 0.0625, parentheses, 4, close parentheses, to the x power. Then look at the t-chart. This matches every single point that I was given. So if you're matching equations to t-charts, you shouldn't miss those. But I did want you to see that you can find exponential functions as well. The calculator can do that for you. Okay, here's everybody's favorite. Okay, first of all, read that first part so I can move it up. I'm going to have to make this smaller so I can fit it. Okay, now we have, is what I'm telling you. This is exponential decay. Sit up and pay attention. Okay, don't worry about what you put in the past. Let's look at it and see if you can figure out the answer now. Think about the initial amount, how much it's changing by, and then look at your answer choices. Which one do you think it would be? It's F. What is it starting at? 5. The diameter of the base is 5 inches. That's our initial amount. Now it's decreasing because they already did the 1 minus for you. That's how they got 0.87. They did 1 minus 13%, 1 minus 0.13. They did the subtracting for you. To the time power. It starts at 5. It's going down by 0.87. I mean, each one is 87% of the one below it. And then this is actually, it's not a time. It's how many rings we have. What were y'all saying it was? Okay, another thing you could do is guess and check the answer choices. Go to y equals. I'm going to put in what the right answer was. 5 parentheses 0.87 to the x power. Okay, now I'm going to go to y equals, and I'm going to look at the, I'm going to go to the table of values. Well, here's my percent of decrease. Alright, so 0, the starting place, look, is 5. Look what the first ring should be. Do you see 4.35? And the second ring is 3.74, something. Okay, so take 5 and find 87%. If this is 5 and this one above it is 87% of that, what's 87% of 5? Yes, 5 times 0.87 is 4.35. If you find 87% of that, you're going to get the next one, which was 3.7845. So you could have guessed and checked and just kind of figured out, just find 75% of each one and write it out. The one that matches that was choice A. If you looked at the t-chart, you get those same values. Okay, try this one, please. Okay, I can look at this and know it's exponential growth. It's not linear, because obviously it's not a straight line. And beware of the word not. They used to, for a couple of years, they didn't even bold it. I think they're going back to bolding it, but still watch out for that. Let's see which one's not true. Okay, the company had 400 stores by the end of 1992. Is that true? Yeah, because this is the years since 1992, and look what they have. 400, so that one is true. They opened 100 stores in 1 year. Well, here's 1 year. We went from 400 to about 500. That's 100 stores. So that's true. Every year the number of stores increased by 25%. Okay, but this is exponential. Exponential is when it's going up or down by a percent. So yeah, that sounds exponential to me. I'm going to hold on to that one. Look at choice J. It opens 250 stores every year. Is that true? No, for one thing, we already figured out it opened 100 this first year. If they opened 250 every year, that would be perfectly linear. If they're opening the same amount every single year, that's linear. This is not linear. It's increasing by a percent. So the one that is not true was this one. H is true. And let's see if we can look at that to test it out. What's the initial amount? 400. No, what exponent would I use? I mean, what decimal would I use? Well, and we got to add 1 to that. 1.25 raised to the x power. Then look at the graph. Or look at the table of values. 0 is, they started at 400. Look what they have the first year, 500. Look at the second year, about 625. That looks reasonable to me. The third year, about 780. Do you see how these are all looking very reasonable? All these points are looking reasonable to me on this graph. So that's true. That is true. It's not J. That would be linear. All right, try this one. How do I know what kind of function it is? It says it right here. Now, yes, I want you to find the equation of this thing. Go to Stat Edit and put all of those in. And yes, this is a lot of work for one question. Some kids were actually able to just kind of continue the curve and get the answer. But just to be safe and just so you get practice on this, let's just do the long way. We're going to find the actual equation and use the equation to find the answer. At least the x values are nice and easy. 0, 5, 10, 15, 20, 25, 30, 35. Okay, oops, I messed up. Okay, so then I'm going to go to Stat, Calculate, and which one is it? Enter, 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 enter. Okay, so it's giving us an A value of 36492 and a B value of 1.08. So then I'm going to go to Y equals and put in 36492 parentheses 1.08. The calculator, when it's doing this for you, it already adds the 1 in there to the x power. Now, where did I get what? From the calculator. When I did calculate exponential. Can you tell me what percent of increase this is? It's not 108. It's an 8% increase. Remember, it's 1 plus whatever the percent is. Okay, now, they wanted us to figure out where it will be at 40 years. How would I find that? No, where would I find the answer? In the table of values. I want the x value to be what? 40. It's not going to be perfect, but it is going to give me the closest answer. 792,000. Which one's closest to that? D. D was the answer. Some kids just said there's a much easier way. Just kind of continue the trend and look at 40 years. And yes, it's going to be close to 800. But I wanted you to see that, yes, you can actually find the equation and use it, even if it's not quadratic or not linear, if it's exponential. All right, I think we have time for one more. Try this one, please. This one is exponential growth, but you could also just continue the pattern. You can, but this one's almost easier if you look. They don't tell us what kind of function it is, but I can tell it's not linear. How can I tell it's not linear? It's not constant, exactly. It's going up by 6, and then it's going up by 12, and then it's going up by 24. What is it doing every time? It's doubling. So some kids just kept doubling, and they went down to 5, 6, 7, 8, and they doubled and doubled and doubled and doubled, and that'll get you the answer too. Okay, don't just guess. Even if you don't feel like entering all the data points and finding the equation, just continue the pattern. 96 times 2 is 192 times 2. And just keep going. 384. What was it? It's going to be 1,536. All right, this is what I'm going to do. I'm going to pass back your first mock test. Keep in mind, a lot of those questions didn't count. Now they will. What I would do is go through, look at all the ones you missed, try them again. That's how you're going to study tonight, is look at the questions you missed and glance through your mock test. Please don't throw it away. It's a great review for when we get to the real thing as well. And then also get a good night's sleep and eat a good breakfast tomorrow.